Hello, algebra students. Mr. Lawrence here. Thank you so much to those of you who tried to watch the video and you were unable to hear the sound. I had a sound problem. I didn't know what it was, couldn't fix it, blah, 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 blah. I did this update to something called Yosemite, and now all of a sudden everything's working again. So this is getting posted really late. I apologize for that, but here we go. First of all, number classifications. You have to know your different subsets of the real numbers. First of all, numbers that you first learned to count with, like 1, 2, 3, on forever. You didn't know about fractions, no decimals. These are called the natural numbers. Sometimes they're called the counting numbers too. The natural numbers, 1, 2, 3, on forever. No zero, no negatives, no fractions, no decimals, unless you consider this to be a decimal. That's the only type of decimal you would get. Okay, then when you got a little bit older, you learned about some slightly different numbers, and you had 0, and then 1, 2, 3, etc. What you were counting with there was the whole numbers, the whole numbers. The whole numbers are just like the natural numbers, except they have 0. There's no fractions, fractions, no fractions, decimals, no decimals, Okay, now I know your definition, the kid definition of a whole number is a number that doesn't have a fraction or decimal, but that's not what a whole number is. Whole numbers also don't include negatives. There are no negatives in either the whole numbers or the natural numbers. Have I said that enough times? You see, the natural numbers go 1, 2, 3, on forever. The whole numbers go 0, 1, 2, 3, on forever. No fractions, no decimals, no negatives. Now the negatives do come into play next, okay, and those are in the integers. The integers, the best definition of the integers, are the whole numbers and their negatives. The whole numbers and their negatives. So you might start with a dot, 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 because there is no smallest integer. And I go -3, -2, -1, 0, 1, 2, 3. And you see how it kind of builds. You know, you had 1, 2, 3 on forever, and then you put 0 on, and then you got brave and went to the left of 0 and considered what happens with values smaller than 0. But again, no fractions, no decimals in the integers. The fractions and decimals come into what we call the rational numbers. Rationals, because rational numbers, the root word is ratio, not rat. Okay, ratio. And it's any number that can be expressed as a natural fraction. Okay, so it includes 1, it includes 5,000, it includes 2/5, okay, 3/12, it includes -5/7. It also includes decimals, decimals that either end or repeat, decimals that either end, a terminating decimal as it's called, a terminating decimal like 2.76, 2 7600ths, or decimals that repeat, okay, like -1.123 and the little bar above the 3 there, right? Okay, those decimals are included with the rationals. Now there are decimals that don't end and don't repeat, and you should know their names. Let me get a different color here. That's called the irrationals. Irrationals. Oops, I need 2 R's there. Ir meaning not. Irrationals. Okay, and those are decimals that never end and they never repeat. Okay, the most famous one is pi, you know, 3.14, and then it goes on forever. Okay, but it also includes things like the square root of 20 or the square root of 21. It would not include the square root of 9. That would be rational. That'd actually be a natural number, right? Because you could think of the 3. Okay, so if a number is not a perfect square and you take its root, then you get an irrational number. That same would go for a cubed root. Like if you tried to take the cubed root of 8, that would be 2, because 2 times 2 times 2 is 8. But if you tried to take the cubed root of 7, there is no number times itself again. That is 7. So that would be irrational also. All right. Then finally, all these together, all of them, including the irrationals, make up what we call the real numbers. Okay, the real numbers. So when you have number classifications, I might give you something like this, 1/2. I might give you a -5, Might give you 0. I might give you 3/7. There might be 25ths. And let's go with the square root of 8. And let's also do the square root of, say, 16. Okay, so we'll try them and we'll see if we can classify them. All right, start with the easiest one that you see up here. Well, the 1/2 is pretty easy, and the 3/7 is pretty easy. They both have the same classifications. Well, almost. I better separate them here, okay? Neither of them are natural. No. Neither are whole numbers. Neither are integers. They're both rational. Okay, so rational. Okay. Of course, they're both real. Real. And this one here, 1/2, is a terminating decimal. Terminating decimal. Okay. This one here, 3/7, isn't a terminating decimal. It's actually a repeating decimal. How would you know this on the test? Well, you'd punch it in your calculator. 3 divided by 7 and see what you get. 0.428571, and it's going to repeat. Yeah, I've shown you that 7's trick before. Repeating decimal. So those are the 3 classifications for those 2 numbers. They're rational, they're real, and they're either one's a terminating decimal, the other's a repeating decimal. All right, let's try 0. 0 is pretty easy. 0 is not natural, but it is a whole number, right? It's an integer. Integer. It's rational. And it's also real. Okay. -5. That one's easy because it's an integer. It's rational. No, yeah, that's right. Thought I made a mistake. And it's also real. You could think about it as a terminating decimal, but we usually don't. Okay, now 25ths simplifies, doesn't it? Down to 4. So that means it's natural, it's whole, it's integer, it's rational, and it's real. I know you don't know those symbols. I've used them before. They'll be on a worksheet I'm going to give you tomorrow in class. All right, finally, the square root of 8 and the square root of 16. Well, the square root of 16 is plus or minus 4. So if you consider the positive one, you're talking about natural, whole, integer, rational, and real. Okay? Now, if you're talking about the square root of 8, there is no square root of 8, so that's irrational and real. All right, there you go. There's your number classifications. Okay, let's see here. We got some equations to solve. Now, these equations have some fractions in them. Remember, if we get rid of those fractions, it becomes pretty simple. I'm going to multiply by the least common denominator, the smallest number that all 3 denominators divide into evenly. I think that's going to be 10, right? So I'm going to multiply by 10 over 1 here, 10 over 1 here, and 10 over 1 here. So the 10s are going to cancel, leaving me with just a plain old x. Here, 5 is going to go into 10 2 times. Now, last time we did this, a lot of you were making mistakes. You would just write down 2 down here. Well, no, you have to multiply. 2 times 2. And it's actually a negative 2 times 2. So it's going to be a -4. I got ready to write 2 times 2. Sorry about that. And then over here, 2 is going to go into 10 5 times. 5 times 3 is 15. Now we have a one-step equation. I'm going to add 4 to both sides. And so x is going to equal 19. And there you go. All right, this quantity here, this equation here, I'm going to choose the same approach. I'm going to multiply by the smallest number that all 3 denominators goes into. I believe it's going to be 18, right? If I know my multiplication facts, math becomes so much easier. Politicians a long time ago said, oh, just hand them a calculator. A lot of you can see how handing you a calculator was the worst thing we could have done to you when you were younger. And I apologize for the schools doing that. 6 times x would be 6x. Here we get 9 into 2 9 into 18 2 times. 2 times 2 is 4. Okay, and then 6 goes into 18 3 times. 3 times 5 is 15. Now we have a two-step equation. I'm going to subtract 4 from both sides. I'm going to get 6x is going to equal 11. I'm going to divide by 6, and x is going to equal 11/6, or you can think of that as 1 5/6, right? Okay, moving right along. Now, we have to do some translations. It says 5 less than twice the number. What does 5 less mean? Does it mean 5 less? Or does it mean 5 less than? Or does it mean 5 minus 5? Which one of these? Well, it's definitely not this one because there is no is here. If it says 5 is less than twice a number, well, then I would do 5 less than symbol twice a number. Now, 5 less, think about it. Let's pretend that you scored 15 points in a game and I scored 5 less than you. Would you do 5 minus 15? Mr. Lawrence scored 5 less than the student. So you do 5 minus 15? Well, that means that somebody scored negative 10 points. How do you score negative 10 points? That doesn't make any sense. 5 less must mean to take 5 away. So you see, 5 less means minus 5, right? So I'm going to take 5 away. What am I going to take it away from? Well, over here, 5 less than this is what I'm going to take it away from. Twice a number. What's the number? I don't know. It's a good thing you don't know. That's why we use the variable. Twice the I don't know. Oh, 2 times n. So 5 less than 2n. There you go. All right, down here, the next one. 7 more than the quantity of 3 less than the product of a number and 4. Don't let it intimidate you. Take it slow. 7 more. That means you're going to add 7. 7 more than what? We're going to have a plus 7, but we don't know what we're going to add 7 to. The quantity of, well, let's start a quantity. 3 less than the product of a number and 4. Okay, so we're going to do this quantity here. And in the quantity, we're going to need 3 less. We're going to need a minus 3. 3 less than what? The product, that's multiplication, of a number, I don't know the number, and 4. So 4 times n minus 3, and there you go. If you want to write it better, you could go like this. And there it is. All right, 2 more quick problems. Factoring. I'm a little bit surprised I have to go over this, but I saw some of your test scores, and some of you just don't get it. Some of you just like went on Christmas break early. We are not on Christmas break, ladies and gentlemen, officially until the end of the day, Friday. I guess in algebra, you could say, as long as you take your midterm on Thursday, when you go home Thursday in algebra, then you're done for the midterm. For algebra, until after break anyway. First rule of solving a quadratic, unless we're completing the square like the honors kids know, but we're not completing the square here, is to make it equal 0. I've got to have it equal 0. I'm not going to factor this. I don't know how to solve a multiplication problem that equals 2, like if it had x times x plus 7 or something equals 2. I don't know how to solve that, but if that equals 0, well, then I know for a fact either this quantity or that one has to be 0. Because the only way to get 0 in a multiplication problem as the product is to multiply by 0, right? So I need this equal to 0. So I'm going to subtract 2 from both sides. And when I do that, I'm going to get a 15x squared plus a 7x minus 2, and that's going to equal 0. All right, what time is it? It's time for ABC. How do you know it's time for ABC? Well, all the like terms are combined, and it equals 0, and I have a trinomial. Okay, those are good signs that it's time for ABC. Easy as 15, 7, negative 2. And so A times C is going to be 30. Now, I know you're saying it's negative 30. It is. I'm just going to ignore the negative, but remember that I have to subtract my 2 factors of 30. What do I have to subtract to get? Well, 7. Well, how about 3 and 10? Now, you've got to ask yourself, a lot of you did this right on paper, but then you didn't translate it right. You said, hey, it's going to be a negative 3x plus a 10x, and I totally agree. But then you got to come over here and you got to rewrite this. You got to go 15x squared, and all of a sudden, a bunch of you wrote minus 10x over here. No, you wrote a negative 3x. Write a negative 3x. You wrote a positive 10x. Write a positive 10x. minus 2 equals 0. Now I'm ready to group. Okay, I wouldn't group if it didn't equal 0. All right, so I'm going to GCF the first quantity, and that's a 3x. And I'm going to have a 5x minus 1. And then I'm going to GCF the second quantity. It looks like it's going to be a positive 2, and I'm going to get a 5x minus 1 equal to 0. Going to GCF one more time. Some of you are stopping short on this, and it's causing you to get things wrong. Okay, make sure you factor all the way. So I pull out this 5x minus 1, I'm left with 3x. Pull out the 5x minus 1 over here, I'm left with a positive 2. And now I have two equations I need to write. 5x minus 1 equals 0, and 3x plus 2 equals 0. I'm going to leave it up to you to solve those two equations. I'm going to get 1/5, and I'm going to get negative 2/3. Okay, one more, and then we're going to end this video. Sure enough, doesn't equal 0, so what am I going to do? I'm going to add 12x, and I'm going to combine like terms. So when I do this, I get 4x squared plus a 5x minus 21. That's going to equal 0. Well, it equals 0. I've combined like terms. Time for A, B, C. Easy as 4, 5, negative 21. So let's see, 4 times 21, that'll be 84. Now, this would be a great time to do the square root trick. Let me see if I can find my calculator on here. Hold on, square root of 84. Let's see. Where'd you go? I thought I had a graphing calculator on here. I must not have one. All right, well, I'm not going to spend too much time looking for it. Ah, there it is right in front of me. Silly Mr. Lawrence. All right, here it comes. It should be opening up. If it doesn't open up right away, I'll just go on to something else. Okay. Oh, I got to activate my license. Oh, fiddle faddle. Okay, so I'm not ready to do that, but I can guesstimate the square root of 84 because the square root of 81 is 9 or negative 9. So I know it's going to be 9 something, okay? Now, I don't know, maybe it's going to be a low 9, like maybe a 9 2/10. All right, now I need to move 2.5 units. Where did I get 2.5 units from? Well, I took half of B. So I'm going to move up 2.5 units, or I could move down 2.5 units. I'm going to move up 2.5 units, and that's going to give me 11 7/10. All right, and that's pretty darn close to 12. Well, 84 divided by 12, let's see, 7 on the nose. Yeah, it goes in exactly 7 times. Oh, and hey, look at that. 9 2/10 minus 2 5/10 is going to be pretty darn close to 7. Yeah. So 7 and 12 happen to be 5 units away. So what if I do negative 7x plus 12x? Right? Okay, so I'm going to come over here and rewrite this trinomial as a 4-term polynomial. And so I'm going to get a 4x squared. I think I'm going to put the 12x next, but notice the positive moved with the 12. I didn't take the negative. It's a positive 12x here. It's got to be a positive 12x there. Minus 7x minus 21. You know, I can almost hear some of you. I can almost hear Colton or perhaps Kelsey going, hey, where did the 5x go? Because they're just thinking, and well, it's right here, right? 12x minus 7x is 5x. So it's still in the problem. It's just a little bit hidden. So I'm doing my grouping. Going to stick that plus in there. And I'm going to pull out a 4x and get an x plus 3. I'm going to pull out a negative 7 and get an x plus 3. Don't throw away that equals 0. Very important. Now I'm going to pull out an x plus 3 and then a 4x minus 7. And now I have two equations to solve. I'm going to let you go ahead and solve them. That is not correct. Sorry about that. X plus 3 equals 0. And then 4x minus 7 equals 0. Okay, I will tell you that my solution set is going to include negative 3 and a positive 7/4 or 1 3/4. Okay, that's it for this first video. Thanks so much for your patience. Hopefully you'll be able to see it. Mr. Laurence signing off. Have a good night, everybody.